everyone, this is Fuge Zou, data scientist from RapidCanvas. Today I'm going to present to you a demo on the use cases of corporate credit rating with an end-to-end solution using RapidCanvas platform. There are three parts of my presentation today. First, I'm going to introduce the problem statement and the data, followed by exploratory data analysis and feature engineering, then end up with model training, model prediction, and Ask AI function using RapidCanvas platform. So let's get started. First, the problem we are dealing with today is one application in financial planning and analysis, short for FP&A. The problem we have here is how to use financial statement data, say income statement, balance sheet, and cash flow statement, to predict the credit risk of a corporation. The data we use are financial statements and credit rating data from the companies that are listed in the stock market in the United States, including New York Stock Exchange and NASDAQ. Here are some business context for this video. You can see in the first chart, the US corporate bond market has tripled its value for the past decade, especially after the Federal Reserve dropped its interest rate during the COVID. Its market value is over $1.5 trillion now. So this is a huge market and very important financial assets for banks, institutions, and investors all over the world. And one fundamental problem to solve with the US corporate bond is its relationship between credit risk and its return or yield. You can see in the second chart, basically showing you a credit risk of a corporate bond throughout the years. And you probably notice a significant jump in the risk bond after 2016. This chart only covers the pre-COVID time. So I'm expecting the trend will shifting during and after the pandemic period. So again, what is it? The definition of the risk here is the inability of firms to repay financial obligation. Basically, it can be interpreted as a probability. And why this is important? Because credit risk is one of the fundamental problems to solve when investing or operating a corporate bond. And it is a $1 trillion market. And all the banks, financial institutions, and investors need such information to evaluate price and return for investment decisions. And our goal is to build an end-to-end machine learning and AI solution for these important problems that will help the decision maker to evaluate risk versus bond price and return. So all the investors, employees, suppliers, and customers from financial institution can benefit from this study. Next, here's a little bit more information about the credit rating before we jump into machine learning. Basically, there are three major rating agencies in the United States, which are Moody, Standard & Poor's, and Fitch. They are very, very famous. This table represents the credit rating from these rating agencies for the best rating to the worst rating. So we start with the lowest risk companies such as Microsoft, Apple, or ExxonMobil, for example. They are probably AAA or AA rating, and move downward to BBB and B ratings to C and D, with D as default rating. And the key takeaway here is that boundary between the BBB and BB rating is where to differentiate the so-called investment grade bond and the speculative grade bond. Here, the investment grade bonds are lower risk and usually lower return, and speculative bond ratings are usually high risk and high return. Our target is to classify bonds as either investment grade or speculative grade, a binary classification for this demo. However, this problem could also be framed as a regression task or multi-classification task, assigning the numerical from 0 or the lowest to 5 as the highest. For simplicity, we focus on binary classification, which remains practical and useful. Now we're moving on a detailed look at the data. The dataset contains over 70,000 records from approximately 1,500 public traded companies in the U.S. companies over the past 15 years. So these records include financial statement and credit histories, requiring extensive data mining efforts. We have engineered approximately 40 features of related to credit risk. Investment grade bonds are labeled as 1. Speculative grade bonds are labeled as 0. The rating distribution between BBB and BB ratings are the most common, with BBB being the investment grade and below BB is speculative grade. The correlation matrix reveals how features like gross profit margin, EBITDA margin, and net profit margin correlate with credit risk, which is our target. Keep in mind, our target here is whether this is an investment grade or speculative bond, grade bond. For example, the higher debt levels often corresponds to speculative bonds, while lower debt ratio align with investment grade bond. Profitability metrics like net profit margin and gross profit margin also differentiate between speculative grade bond and investment grade bonds. Highly profitable companies tend to be more investment grade, and with less profitable ones become speculative grade bond. These insights help identify key features for machine learning models. We can also build a quick financial analysis for the company we are studying. For example, this is Amazon's past 10 years of financial data. You can see we have operation metrics such as revenue growth, gross profit, R&D expense for Amazon's. We can also look at the management metrics such as non-current assets, asset turnover, operating asset turnover. Not only this will help the bond, how to evaluate the bond credit, also can evaluate how strong this enterprise is. The debt metrics also is related to the rating of the bond, right? You have total liability, total debt, current versus non-current liability for Amazon's. You can also look at the current ratio, see what is their cash position for this company. And last not but least, you have profitability metrics such as net income, tax rate, net income multiples, and return on equities for each company. So in that case, you will have this traditional way of looking at companies' financials. Based on this understanding of the data, now it's time to put everything into our platform, which is the end-to-end machine learning solutions for for the binary classification between investment bond and speculative bond. First, we have balance sheet data, cash flow statement data, income statement data, and credit ratings. We have scraped all the U.S. Companies in the U.S. stock market and merged them into one big file, and we split them into train data and test data. The criteria for train and test data is we say everything before 2019 are train data, everything after 2019 are test data. So we have so our test data is like blind testing of the model. So we built the model based on the train data, and it is by using our RapidCanvas rapid model, which is AutoML. We can say this is our input data, and we set the target. And for binary, this problem type is binary classification, and we hit run. So the model will automatically generate, automatically generated, having all the hyperparameter tuning, find the best model, including XGBoost, light GBM, linear regression, support vector machine. The modeling process is going to try all the necessary model that we can make a binary classification, and will output some artifacts and output a model summary. So let's look at the model summary. You have net profit margin as your most important features for the model. So the higher net profit margin is, the higher likelihood to be investment grade, right? And you can look at the high advanced model insights where you have log loss, you have the features, you have all these like ROC curve. These are the machine learning specific criteria, and you have this AutoML summaries like what kind of model the model has tried and what is various important feature heat map. After that, we apply the model into the unknown data, which is the test data, right? Remember, the train data is based on the training process is only based on the train data, but we are going to apply this resulting models to the test data, and we're going to see how good the test data is. So you can have this confusion matrix where you have your false positive, false negative, true positive, true negative here. And you also have this like error, what is the error look like? What is false positive, false negative? So let's go to a model summary here. Like I said, we have tried everything before 2019, everything after 2019 as test data, everything before 2019 as trained data. We have the best model, which is GBM model. And our model performance is for the cross-validation score, which is trained data, is 90%. While the test score is dropped a little bit. That is probably because after 2019, that's COVID time, right? The data is skewed, the model is drifted towards the COVID time. So this is like a special time that will make the model drifted a little bit, which is fine. We still get very high accuracy here. And this is a model explained for shapely plot, and this is the feature importance. And these are the data science specific charts. If you are not a data scientist, you can ignore this. The next one is model prediction, where we have trained the data when we are trying to apply to the new data set, where the new ratings coming in and how the model performs, right? You can say, for example, using Apple as example, right? You can say we are trying to forecasting Apple in after 2019, and based on the features we have. Apple has very good return on equity, which is a positive drivers. Have good net profit margin is a good positive drivers. However, Apple also have very high debt ratio because they are trying to maximize the return on equity. So Apple's debt ratio is kind of high too, which is a negative driver. But overall, Apple is definitely a yes for investment grade bond. But here is also you can try what if analysis for Apple. What if Apple's net profit margin is going to be negative? How will that affecting Apple's credit rating bond, right? If you say Apple has a negative profit margin, the new predict results based on this slider bar is give you the negative example, right? So if you say Apple's negative profit margin is negative, its overall rating is going to be negative. So this is a sensitivity what if analysis for based on the key drivers. The last not but least, this is the Ask AI chatbot we have. We can have this like AI agent. We put all the data we have and put them into Ask AI chatbot in our platform. And you can say in the cash, this is a cash flow statement where you can ask questions based on this data set, right? You can say, show me top 5 company which has the strongest cash flow in 2021. Boom, the data is going to give you HSBC, Apple, Google, Microsoft, ExxonMobil. So these have a very strong cash flow, and you can ask questions based on the balance sheet, right? So you can say plot NVIDIA's asset in the past 10 years. So it's gonna plot NVIDIA's asset in the past 10 years. How about income statement? Say top 5 company symbols by revenues in 2021. So it will give you the company with the highest income revenues in 2021. And it also shows, I'm also asking top 5 company which has the highest EBITDA margin with revenue more than $10 billion in 2021. So I'm going to look at all these big companies with the highest EBITDA margins like Netflix, Verizon, right? Some things like that. Also, I'm asking questions regarding to the credit rating. So compare the credit rating of Apple in 2019 and 2020. So it will generate Apple is 2019 versus 2020. And show me top 5 company whose rating dropped from 2019 to 21. This is like effect of the like COVID, right? During the COVID, companies' rating actually dropped. So these are, so for example, QEP Resources, they are oil and gas. Gartner also dropped their, Southwest Airline dropped their credit rating. So the top 5 company which has the most investment grade ratings, of course, AT&T have the most investment grade rating. So I'm asking, compare the credit rating from different agencies on AT&T. So it will have Standard Poor ratings, Fitch ratings, and Moody ratings in different time. So this will basically this chatbot is very smart on understanding these ratings. These like question I have. Or you can also basically, if you like some charts, you say like, I like this chart, I'm gonna add them to the data app, so I can see them in the data app. So this data app has been saved as in the data app, so you can view them later. And also, if you wanna build your own data app, you can create an app in our data app. Our data app, actually you can create them based on the models, based on the data. And also you can put this in the cron job where you can run this every day. If you say these are connected to your Snowflake database or connecting some online scraping bot, so you can probably connect this to every day. You can get the latest ratings and their agencies and all the financial data. That's all for this demo. Thank you very much. Have a nice day. Bye bye.